Okay, let's just dive right into this. Today, we are transforming intimidating Cambridge additional mathematics past papers into an absolute strategic blueprint for your exam success. Look, what we are really doing here is building bulletproof arguments with stress-tested evidence and extreme quality control. And honestly, whether you're studying for syllabus code 0580, 0606, 4204, 4037, or 4040, the core challenge is exactly the same. You see, I want you to imagine a dynamic split screen in your mind right now. On one side, we have a student named Alex. Now, Alex works hard, but Alex overloads their exam paper with raw mathematical facts, just literally dumping every formula they can possibly remember onto the page with absolutely no logical analysis. And then on the other side, we have Sam. Sam is constantly rushing against the clock, sweating, entirely missing the specific requirements hidden within the command words of the question. Both of them are throwing away incredibly easy marks, and their papers? They're just absolutely covered in the examiner's red ink. Well, today, in this explainer, we are going to fix exactly that.
So if you're looking at a multi-step polynomial question like this one, the ones that just make your brain freeze up, it's super easy to see where our two students, Alex and Sam, completely fall apart. Alex will instantly start doing long division for pages and pages, right? Getting completely lost in a sea of algebra, panicking as that timer just ticks down. Sam, on the other hand, will try to skip right to simultaneous equations without ever stating the underlying theorems, instantly losing vital method marks along the way. But to secure maximum marks, we need a flawless, stress-tested system. We need to identify those critical command words, like show that and find, and map our algebraic equations directly to the underlying rules without any wasted effort. It's about working smarter, not just harder.
All right, here is our masterclass agenda for today. We'll quickly cover the exam strategy blueprint, then master composite and inverse functions, move into the geometry of functions, tackle quadratics, and finally conquer those massive polynomial theorems. Let's jump straight to it. Section 1, the exam strategy blueprint. We're talking about building logical, manageable steps. To build these steps perfectly, we are actually going to adapt a framework you normally use in essay writing, known as PEEL, and we're applying it to elite mathematics. Okay, so P stands for point. You identify the command word and the exact mathematical condition required. E is evidence. This is setting up your specific formula or theorem. The second E is explanation, your clear, step-by-step algebraic working. And L is link, linking back to the final required format, complete with specific constraints. Apply this exact framework and your answers become completely bulletproof. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Section 2, mastering composite and inverses. The mechanics of working backwards. Let's really get into the fundamental mechanics of functions, specifically looking at how we reverse engineer them. Now, Alex usually looks at an inverse and tries to just flip the signs randomly, which is an absolutely catastrophic error. It hurts to even watch. We need to follow our PEEL framework to ensure we are actually performing the correct mathematical mechanics, step by step. Before we even calculate a single thing, let's establish what an inverse actually means. Think of it like a mathematical rewind button. The mathematical condition of an inverse function, which we denote as f inverse of x, is that it perfectly reverses the original operation. But here is the absolute secret sauce. The thing that separates the top-tier students from the rest, understanding the mapping. The domain of your original function becomes the range of your inverse. The range of your original function becomes the domain of your inverse. It's a complete swap. When Sam rushes through questions, Sam completely forgets to define this new domain and range, instantly dropping at least 2 grade boundaries worth of marks over a whole paper. We are definitely not going to make that mistake today.
Now take a look at question 2A from the review exercise. How do we actually find this inverse expression? The command word here is find, right? That means we need to produce a clear algebraic expression and, crucially, show our working. Also, notice that very specific condition given right at the end. X must be greater than or equal to 0. That is the domain of our original function, and as we just established, it's going to become incredibly important when we define the final parameters of our inverse. If we're truly stress testing our answer, we know that ignoring this domain constraint is exactly where the examiner's red pen is hovering, just waiting to strike.
And this brilliantly illustrates the exact methodology you need to follow. This right here is the explanation part of our PEEL framework. Step 1, we set y equals x squared minus 1. Step 2, we use our algebraic skills to isolate x, giving us x equals the positive square root of y plus 1. Step 3, we literally just swap the variables. If you were Alex, you might get totally lost moving the -1 over, maybe messing up the signs. But by using our clear 3-step system, you just perform the inverse operations methodically. Add 1 to both sides, then take the square root. It is clean, it is logical, and it guarantees that the examiner can follow your exact train of thought to award you all those juicy method marks.
You lock in full marks by not just finding the expression, but correctly stating the new domain and range based on the original function's constraints. Remember the L in Peel? This is the link. We link back to the constraints. Since the original function's domain was x is greater than or equal to 0, our inverse's range is f inverse of x is greater than or equal to 0. And because the lowest possible value of the original x squared minus 1 is -1, our new domain is x is greater than or equal to -1. This is extreme quality control in action. You've built a bulletproof mathematical argument that leaves absolutely zero room for the examiner to deduct a single point. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, moving into Section 3, the geometry of functions, seeing the algebra visually. Visualizing mathematics is honestly the ultimate cheat code for Cambridge exams, and it completely prevents that blind, panicky memorization that holds students like Alex back. Let's see exactly how this works.
Question 2b asks us to sketch this. Now let's treat this like a 60-second data scan challenge. When you see a command word like sketch, what does the examiner actually want from you? Sam always loses marks here by spending 10 minutes sweating over plotting exact decimal coordinates. Remember, a sketch just requires the broad mathematical truth, the core trend, the intercepts, and the general shape. We just need to show the upward curve of x squared minus 1 and the sweeping curve of the square root of x plus 1 while paying strict attention to those domains we literally just calculated. This side-by-side perfectly bridges the gap. The pure algebra on the left physically translates to a mirror image right across the line y equals x. Now let's play Find the Flaw. Imagine Sam writes a paragraph that says, the inverse is just the same graph moved up and turned around. Can you spot why that loses marks? The precise mathematical terminology required to actually secure the mark is reflection in the line y equals x. If you don't use the specific word reflection and specify the exact axis of symmetry, you get 0 marks for the geometrical relationship. The algebra is literally mirroring its inputs and outputs, which is exactly why it reflects perfectly diagonally across the Cartesian plane.
Section 4, Quadratics, Tangents, and Roots, translating visual conditions into algebra. Let's apply this visual algebra connection by treating each problem condition like a mini exam boss to defeat. How do we take a visual concept and turn it into math? Let's dive in.
Take a look at question 6. It asks about a line being a tangent to a curve, which is a geometric concept we absolutely must translate into an algebraic equation. The command word is find, and the specific condition is tangent. Sam would rush this, right? Sam would maybe try to take a derivative, get totally confused by that unknown letter k, and just abandon the question entirely. Alex would just try to plug in random numbers for k, hoping something works. Both fail. The stress-tested strategy requires us to realize that finding the intersection of a line and a curve means setting them equal to each other, and the word tangent is the ultimate clue for the specific tool we need to pull out of our mathematical toolbox.
And here is that tool. Notice how this table directly organizes the data into a cheat sheet recap graphic for you. Tangent means exactly one intersection point, so the discriminant equals 0. While above x-axis from question 7 means there are no real roots. The discriminant, b squared minus 4ac, is the engine that drives all quadratic analysis. If a line is a tangent, it grazes the curve at exactly one point, meaning there is only one real solution. Therefore, b squared minus 4ac must perfectly equal 0. If a curve lies entirely above the x-axis, it never ever crosses it, meaning 0 real solutions. Therefore, b squared minus 4ac must be strictly less than 0. This is translating visual geometry directly into hard, undeniable algebra. By following these 3 steps, we completely eliminate the guesswork and systematically trap the exact value of k. Let's trace the working carefully. Step 1, we equate the line and the curve. 8x plus k equals 2x squared plus 8x plus k. Now, step 2 is absolutely crucial. You must rearrange this chaotic mess into the standard quadratic form of ax squared plus bx plus c equals 0 before you do anything else. Do not skip this. Once it's neatly arranged, step 3 is deploying our condition, setting that discriminant equal to 0. If you lay your working out exactly like this on the page, the examiner can easily follow your logic, and your mark potential instantly rockets straight up to 100% for this particular question.
Section 5, Conquering Polynomial Theorems, the ultimate test of logic. Now for the climax of our explainer. We are combining all of these analytical skills to conquer multi-step polynomial problems. These are the big ones, folks.
Multi-step polynomials are notorious for overwhelming students because they present you with these huge, dense paragraphs of text. But we must first anchor our strategy in these two theorems before facing the heavy algebra. The factor theorem and remainder theorem are essentially the exact same rule, just with different outcomes. Think of it as a substitution machine. If an exam tells you that x minus c is a factor, your immediate reflex, your point and evidence from the Peel structure, must be to state that evaluating the function at c will result in precisely 0. If they tell you there is a remainder, evaluating at c equals that exact remainder. By explicitly writing down f of c equals 0 or f of c equals r on your exam paper, you instantly secure your first method marks before the deep calculation even begins.
Let's bring back that incredibly intimidating question 9 from the very beginning of the explainer. Now, equipped with our stress-tested strategy, read it again. Factor of x minus 1 is no longer just a bunch of words. It is a direct mathematical trigger. Remainder of negative 50 when divided by x plus 4 is another distinct, actionable trigger. And look closely at the command words. Show that b equals negative 6 and find a. Show that is a strict command, meaning the examiner already gave you the answer. But listen to me. They will give you 0 marks if your algebraic steps to get there aren't absolutely flawless and transparent.
Notice how the theorems give us exactly the two equations we need to unlock the constants, turning a terrifying dense paragraph into a straightforward 3-step process. In step 1, we substitute x equals 1 into our massive polynomial and set the whole thing equal to 0. This generates our first linear equation with a and b. In step 2, we substitute x equals negative 4, carefully managing our negative sign so we don't mess up like Alex would, and set it equal to negative 50. This generates our second linear equation. Finally, step 3 is simply solving these simultaneous equations. We've taken an overwhelming problem, decoded the command words, and created a simple, stress-tested pathway straight to the solution.
By executing those simultaneous equations, you confidently arrive at b equals negative 6, proving the question right and securing maximum marks. And here's the beauty of it. Because it was a show that question, arriving at negative 6 is your built-in quality control. If you calculated it and got negative 8, you'd immediately know to go back and check your negative signs during the x equals negative 4 substitution. Once you prove b is negative 6, you simply substitute it back into your linear equation to easily find the exact value of a. You've completely bypassed the panic and confusion that plagues students like Alex and Sam, relying purely on structured logic and our exact framework.
The relationship between algebraic steps and visual geometry is your ultimate blueprint. By decoding command words, applying the Peel framework, and mapping equations systematically, you don't just solve problems. You construct bulletproof arguments. You've seen the matrix behind the math. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.